So to start with the topics, we have first is predicting molecular shapes using this theory, which is Vsepr theory. So later on, we will know what is that abbreviation. And then next is non-covalent interactions and forces between molecules. So we only have two topics in this chapter. Okay, let's start with the objectives. So you should be able to perform modeling and then predict molecular geometry and predict the polarity of molecules. Okay, so let's start with the first topic, which is predicting molecular shapes. Okay, so since we are already in the midst of studying chemistry, so we must know that there are molecules, there are compounds, okay, but how do these molecules exist in space? Okay, and will there be any implications regarding the shapes of the molecules? So this topic, okay, will cover these questions. Okay, so first let's start with the shapes, or the different shapes of the molecules. So the shape of the molecule is known as the geometry of the molecule. So geometry or shape, so they are interchangeable words. And we use VSEPR theory, or the valence shell electron pair repulsion theory, to predict the shape of the molecules. So how do we apply this theory? Okay, so first, okay, so sorry for that noise. I don't know if it is caught, okay, in the microphone. Okay, so imagine if you have uh, three balls representing atoms, and one of these atoms act as a central atom. So there is one in the middle, and then there are two balls, terminal atoms. And how would you position the remaining two balls, or the two atoms, so that the covalent bonds, okay, which we know have electron pairs, are found at a maximum distance with each other? Okay. So, and what is the bond angle formed, okay, from these 3 points, or from these three atoms? Okay, so just try to imagine first, and then we'll see on the next slide how it is formed. So we have this, so we have the central atom A, and then we have the two terminal atoms, which are marked as X. And then we have the covalent bonds here. Okay, so they are positioned like a straight line. So the bond angle is 180 degrees Celsius. Okay, so they are at their maximum distance apart, since we know that these electrons and these electrons from the covalent bonds, so they are repelling each other. So again, electrons, we have negative charges, so negative charges here, so they will repel. So that means they must not be in any contact which is below the maximum distance from each other. Okay, so we have here the geometry, which the electron pair geometry, which is linear. Okay, and the molecular geometry also linear. So later on, we're going to discuss the definition for this. And then we have here the type. Okay, so AX2E0. So this means that we have the central atom A, and then we have two terminal atoms X, and then we have 0 electron lone pair. So we do not have any lone pairs or electron lone pairs around the central atom. Okay. So let's define this AXE notation first. So in AXE notation, just like the one that I had shown you earlier, so A refers to the central atom, and then we have X, so this X refers to the terminal atoms, and then we have the subscripts. So this refer to how many X or how many terminal atoms or how many E lone electron pairs are around in the central atom. So going back again, here we have two terminal atoms and we do not have any lone electron pairs here in the central atom, so we have 0 here. Okay, so that is just like writing chemical symbols. Okay. So next is we define the electron pair geometry and molecular geometry. So electron pair geometry, okay, so this is the shape of molecule which is determined by the number of electron pairs around the central atom. So these electron pairs could be the lone electron pairs and the bonding pairs. Okay, so this means that this geometry, this is the shape wherein we account all the pairs of electrons around the central atom. While molecular geometry is the shape of molecule, which is the arrangement of atoms in space around the central atom. So this means that we only take into account here in the molecular geometry all the bonding electron pairs. So this is because the lone electron pairs are just electrons which move around very quickly. Thus, we cannot see it when we look into a molecule. Okay. So this molecular geometry is what really is the shape of the molecule if we look at a tunneling microscope. Okay. So let's have other uh, shapes or other geometry that uh, there can be in a molecule. So we all saw this one, the linear geometry. So next is if we have a central atom and we have three atoms or three terminal atoms. So they are positioned again at their maximum distances apart so that the bonding electrons uh, will uh, will have the maximum repulsion with each other. So this is in a plane. Okay, so and this forms a triangle. So this is called as triangular planar or trigonal planar. Next is we move on if we have four terminal atoms. So we have AX4E0. So this time we will have a three-dimensional model. Okay, so this one is just one dimension. So we just have here from left to right. Okay, we only have a straight line. And then here we have a plane. Okay, so we have an x and y coordinates here. And then here, if we have four terminal atoms, so we'll have to use our imagination so that we can see the proper placement of the terminal atoms. Okay, and we will use that three dimensions. So I will cut this video and then have the next discussion on the next video.